Well, hi, and thanks for joining me in my shop here. And very soon, my buddy Scott will be joining us on the telephone once I give him a phone call. But just to recap what happened in yesterday's video, basically we focused on this component here, which is a wire wound resistor with a slider on it. And as it turns out, that's the right component for sure to focus on. Turns out it suffered basically a devastating failure, I guess you could say that. The wire is shot on the wire wound resistor. So we ended the video thinking about, well, what we could do next. And the part of the idea was to replace this with a similar resistor, another wire wound one, I suppose, to carry the kind of current and heat dissipation that's expected of this component. And also another idea was to hook up some resistor boxes. I have a resistor box right here, and change the settings, and in a sense be moving the slider back and forth just by changing the resistances. I have another box right here. I have two of them, so I could use two of them to kind of imitate the arrangement here with the wire wound resistor. So last night I came in. These boxes are old, of course, and I try to use all kinds of vintage stuff in doing this work. And old stuff has problems, and these certainly have problems. When you turn the setting here, instead of 15 ohms, you might get 20. Instead of 22, you might get 31, and on and on. So I thought, why don't I just take a look inside, and just to see what's going on in here, in case there's something minor I can fix. And the first thing, you can see these resistors sitting here, 4 of them sitting here. I looked in there, and to my surprise, and I shouldn't have been surprised, I found a bunch of blowed up resistors. Well, cracked anyway. Actually, various states of failure. This one here is the one that caught my attention. Look at that, eh? PYE. That must have been a pretty good smoker. That might have even made a popping sound. I don't know. So that was pretty obvious that somebody switched or used this box in a circuit that conveyed too much power into the resistor here. Boom, gone. And then I have another one here. Whoops. Kind of similar. Another PYE. But as I got out my magnifying glass and started looking closer and closer at these resistors, well, you know what? This is a potential replacement. This is not a bad one. That's a potential replacement I dug up. There's another one with a crack in it. So, it could have happened 1, 2, 3. Somebody could have had that box hooked up to some fairly significant source of current and just started switching the dial around, and you get the wrong combination. The heat dissipation in the resistor is beyond its rating. I mean, these are fairly highly rated resistors. I think those are 1/2 watts. I don't know my resistor wattages to look at them very well. That might be a 1 watt or a 1/2 watt. Anyway, I've replaced these resistors. Somewhere along the line I did something wrong. One of these settings is way off now by a factor of 10, so I think I put in the wrong resistor. But that's okay. It really doesn't matter. We may not even use these because my buddy Scott must be wondering what I'm doing here. Maybe I'll give Scott a call before I do the next part of this. So let's call him up here. I'm sure he's anxiously waiting by the phone. So not only can I not fix radios, I can't work telephones. I mean, who can work these phones anymore, for crying out loud? Holy smokes.
Good morning.
Did that work?
Yeah.
Okay, great. Okay, well, Scott, what I've done here already on video is just kind of gone over where we left off yesterday with the defective wire wound resistor. And I showed what some of the resistors looked like that came out of the decade box that I fiddled around with last night, which I thought I'd take a moment and just check it out, and I ended up replacing 4 resistors in it. And I found 4 wire wound resistors, which I thought I should start the video, I should call you up so you can see them too, but you can't see anything there. You're just on the phone.
Yeah, I don't need to see them, but I've been thinking about this thing. I was looking at that circuit for transistor 4. The collector resistor R21 is 2.4K, so your maximum out of the 25
Whoa,
10 milliamps.
Whoa,
So I don't think it's really critical.
Slow down there, okay? I'm just looking at the circuit diagram here. So what were you saying again?
Okay, the resistor R21 there, the collector resistor for transistor 4,
Oh,
that's going to limit the current. It's 2.4K, and it's a 25 volt supply. So
Okay,
you're not
okay,
going to
whoa,
get
whoa.
more than 10 milliamps max.
okay, so slow it down there, okay? You're going, you know, I can barely find my find the resistor on the schematic. You're already three.
Right at
three
the top in the middle.
So I'm looking. 21 is 2.4K, but right below it is
Right.
another one in series.
It's 87 ohms or something. I think that's just the bias, the basis between transistor 5 and 6 there.
Oh yeah, 82 ohms. You're right. So it's a little
Right.
tiny resistor, R22, and like you say, it's setting up the bias in transistor number 5. Yeah. Okay. So you're saying, so this R21 is so big, what does it really matter with R?
Yeah, it's maximum. If transistor 4 was shorted out, you'd only get 10 milliamps flowing in the circuit. So I don't think it's really going to be too critical that it's a wire wound pot for RV5, because it's only going to be maximum 10 milliamps flowing.
So you think even a regular carbon sliding type
It
potentiometer?
could work that far. I don't know.
Yeah.
Maybe over the long term.
Well, you know, this is something that you.
The carbon pots may not like DC over the long term, but I don't know. I don't think it really is a big deal. Wire wound pots were normally used because you needed power dissipation.
Right.
But 10 milliamps flowing in 300 ohms, there's going to be squat power there, so it's not really.
Well, I think I'd like to stay away from the pot idea, the carbon pot idea, for two reasons. The main one is I don't think I got one that's anywhere near 300 ohms. That's pretty weird.
Right.
And the other one is my experience is when you have a little bit of DC flowing through a control like that, certainly if you turn it, you can hear it.
Right.
Now this one won't be turned, right? This would be set once and forgotten about. But I'd much rather take the route of putting permanent resistors in.
Okay, you said you have multiple wire wound pots there in your.
Well, I have 4 of them, but none of them, like a couple of them are for, you'd use them in your automobile for front to back speakers back in the 70s, you know, for changing
Right.
or maybe in your house even, and those are very low resistance. Very low, 80 ohms, something like that, 60 ohms.
Okay.
And then I have a couple others, which I've forgotten. Let me get this on camera here. As if I'm not normally overwhelmed with cameras and videos, now I got you on a phone too to try to. I got to be thinking 3 things at once. So I'm holding one here in my hand, which would be ideal if it's the right, or if it's a usable resistance. And I know I concluded none of them were, but I can't remember what the actual values were. So I'm going to measure this one again, just on the outside pins. Yeah, see, this one is 20 ohms on the outside pins. And then I have another one here. This is looks like an expensive thing. Okay, and it's over 2K. $3.3K. And that's kind of what I got. So there's nothing close to the 300. I mean,
Well, you could maybe flip lead in. You've got a fixed 150K resistor, say, out of your resistor cabinet.
yeah.
Flip lead that in on one side, and then just use that 3K pot as a rheostat for the other half.
Thought about that. Yeah.
Vary it and see what resistor you need to put next to the 150.
Oh, okay. I see your approach. So, well, I have a 150 right here. Yeah. Using the potentiometer is better than trying to use the decade box, because the decade boxes jump. Too many. Their steps are too wide on them, on both of them. But one of them doesn't even really go.
Yeah, so you could just use that one wire wound pot you have like a rheostat, and one half of that, variable resistor there, and see what you get.
And you think I can clip all this in, eh? Except the other one is still in place there. I have to.
Well, you'd have to disconnect the wires from it.
Yeah, I'm gonna have to do a little bit here.
Get the solder iron turned on.
No, hang on one sec. Okay, so what I've done is I just kind of twisted in a 150 resistor on one leg, and the other leg I'm going to use one of these wire wound resistors. I'm just trying to pick which one to use here right now. Once again, I've kind of forgotten what the values were. I have to retest them. So this one's 20. That's no good. I think maybe it was this weird one here. I'm doing the hold the thing and the voltmeter leads and all that stuff challenge here. Wow, it looks like it's 3.3K. Okay, now what I'll do is I'll turn it down all the way and see what we get from the wiper. What a hassle. Give me a clip lead. Don't know where this came from. I was going through my parts boxes. First of all, I was very disappointed. I thought I had a lot more parts. But I guess over the years, they've leaked away. Okay, here we go. Well, 0. Turn it up a little bit. Uh-oh. 300. Oh, you know what? That's with almost no travel in the control. Let me clip the ohmmeter right on. I got to do a proper test here because I can't. You know, some of these things will come down close to 0 and then skip right at the end and stuff like that.
You can try it from both ends because it might not be a linear one as well.
It's very unusual looking. Okay, now we're hooked up. Now we're hooked up. Okay, so that's 200 ohms. I can easily set this. It's going to be somewhere in the range of 150, right?
Okay, sounds a good place to start.
Well, I'm just seeing how easy I can adjust this. It's just going to jump all over the place. It's a very small control. It's a little hard to hold on to the knob. Looks like with a lot of care, I can set this to within 5 ohms.
Have you got a knob sitting around you can put on it just to make it easier to turn?
No, because I have to hold the control anyway. So I'm using a tool. So I've set it to one. It's set to 150, and it actually has little lead wires on it already. Isn't that handy? So all I got to do is just put that on the other side here. I'm not going to use clip leads again. I'm gonna tack solder this stuff together because we're dealing with fairly low resistances, and any little wonkiness is just going to drive me crazy.
Yeah, sounds like a good idea.
So I will be moving this stuff around as I have to manhandle it a bit. Okay, that's one side. I've let my bench get all messy here, which I don't like to do. Too many things on the bench, I can start getting confused about where stuff is and that. Okay, I'm just tacking the wires now. Okay, I got one last one to tack on here. Well, once we determine what the correct resistances should be, then I'm going to have the challenge of trying to find the right fixed resistors, and you know, I got thousands of resistors in here, but they're all, you know, most of them are the standard resistor values. They're not any old thing you want. Actually, I got two sets that use, one set uses the standard values, you know, 33, 39, whatever it is. And I got another set of resistors which are all in decades. 10,000, 20,000, 30,000. Okay, so I've now soldered in the control. Let me make sure. There's lots of potential for short circuits with this control here. So what I'm going to do, I'm going to baggy it a little bit. Okay, I'm practicing now. I'm going to hold it. Okay, it's in there. It's I got to think about which way to turn it too. If I turn it counterclockwise, that will reduce its resistance. So the objective now is to measure the voltage on the center slider, which is really the point between the fixed resistor and the variable one now, and see it go to zero. Against
No, you don't want to measure the voltage there. You want to measure the voltage between the collectors of two transistor 8.
You're right. You're right. So I want to measure between the collectors, you said.
Yeah.
And that's
the case, basically, of the two transistor 8s, like we did yesterday.
Oh, right, right. Because the collectors are the case. The case is the collectors. Okay. Let me get my voltmeter clipped up for that. I'm not going to want to be holding it. Okay. Yeah, see, I got so much stuff piled up on my bench now, I got to dig things out to use them. I should really have cleaned up my bench last night. That's what I should have done. But, you know, I thought it'd be 5 minutes on the decade box, and I was in here for an hour messing around with it. Okay. I think we're set here. So what I will do is I'll check the resistance across the whole thing now. Oh, I'm using my meter. Okay. Resistance across the whole thing. It should be around 300. How's zero grab you?
Measuring across
Oh, there we go.
one end of the 150 and the other end of the plot.
That's what I'm trying to do. I was getting zero there, but I think it's just bad lead contact. Okay, it says 270. That's pretty good, eh?
That's a good place to start.
270. Now, the way the slider was, to imitate how the slider was, I should be starting a little bit above, like assuming the slider was in the right spot, and that even though so much time has gone by and things have aged, starting roughly where the slider was would make sense. So instead of it being 150, 150, it's probably more like 120, 170. So with a 150 fixed resistor, probably I should raise the variable a little wee bit. Okay, which I'm just taking a guess at here. 127. So when I go to turn the knob with my fingers, I can't even feel if it's turning. Oh, it did turn. 240, a little too high. Because we're just down at the end of the run here on this control, it doesn't take much.
Yeah, and you've got the speakers unplugged, right?
Speakers are unplugged. 220. This is exactly the problem I'll have when we actually do the do the experiment here. Okay, wait a second. I really want this to be at the right starting point, and I want to make sure I know which way to turn the dial. So I'm clipping my ohm meter back onto the variable here. Wow.
I assume you're going to start this
Whoa.
out on restricted power, right?
It will be restricted, but if things are operating normally, the restriction doesn't really restrict much, right?
Right.
Because
So then you'll want to put it on full power just to confirm that it's...
Yep, true enough.
Right, okay.
Okay, now for some reason with clip leads it says 245. I thought I was right near the right spot here. Okay, so I wanted this to be like 180. Oh, there we are, 180, 182. Hey, isn't that a band? Blink 182?
Something like that.
Okay, so 180, so that should now be just a little more than 300 across the whole show. Let me just double check that. 320, 325, so we're there. Okay, so I'll set my meter back up for voltage between the collectors of the two power transistors, which are their cases. Better change my voltmeter to volts. And just checking now to make sure everything is ready to go. No accidental short circuits anywhere. Got these plastic bags in place to kind of keep the loose boards from shorting on the metal chassis. Just double checking them. Okay, we're good to go. We're good to go. No speakers connected. Voltmeter at the ready. So, Scott, I turned this thing on. Is there a voltmeter reading at which I should go, oh my God, and turn it right off again?
No, only if you're looking at a huge power dissipation. Otherwise, really the voltage is just going to be whatever it is, and then you have to try and zero it by varying the control.
That's right. The whole issue here is anything getting hot? And since we don't have the speakers connected, there's really no current involved in this problem now. So really, you're right. There's really not much risk to this. That's my story. I'm going to stick with that. Okay, I think we're ready. I'm very hesitant at times like this, as you probably know. Okay. Voltmeter set to 20 volts. Switch on. Ooh, that's not too good. We have minus 15 volts on there. The light is on bright, as we would expect. So the power supply is not strained. It's gone to minus 14. Why would that be?
Well, because the thing is out of its adjustment. You need
That
to,
much?
You know,
Wow.
I'm not sure just how sensitive it'll be, but give
Okay.
it a turn, see what happens.
Okay. Keep my eye on the voltmeter, because just picking up this control is enough to make a little bit of a change. It's so sensitive. Okay. Okay, I'm ready to turn the control here. I am turning it. It's going up and down. Okay, I got right to the limit, and it's just okay, I'm going the other way now. It's not working. Okay, so I got hundreds and hundreds, maybe even 1,000 ohms now in here, and the voltage remains the same, minus 14. I've turned it, and I know I'm turning the controller because I can feel it when I hit the stop.
Right.
Isn't no difference. It's making no difference. No difference. Oh, that's disappointing.
Okay, I think what you need to do is power it down and swap the two wires that would be the ends of the outside ends of the pot around.
What you're thinking there?
Well, because I think you're too much towards one side. You've got fixed 150 on one side and a variable on the other, and I think you need to go the other way and have the variable with 150 it.
Oh, I see what you
know what I
mean.
mean?
So in other words, all I'm doing is just kind of going up and down in the danger zone. I'm not really...
Yeah, you're going towards the worse rather than towards the better because it's backwards. There's no way
Okay,
of
that's
knowing
true.
until you try it,
That's
but
right. That's
what-
because we started with a 150 and not with like a 100 or something like that. If we'd started with
you
a...
might need the lower resistance on the 150 side rather than on the side where you have the pot.
Okay, so just to show you how confused I am, I went to turn the power off to this unit here, and I reached for my computer mouse. That's where my head's at here. So I got a little overloaded. Okay, so what we got to do then, since I soldered these things, I got to unsolder them and move them around. Warm up my soldering iron here. It timed out. Okay. Now, you know, when I put these wires on, I crimp them down pretty tight onto the resistor. They may not come off easily. When I said tacking, I did a little more than tack. Okay, one's off.
Tacking if you do it too well.
One's off. Apparently I'm a bad tacker.
I remember one time I forgot to tack when we tacked and I got hit in the head with the boom.
It's a different kind of tacking.
Yeah.
Okay, now. This time I will truly tack the wires. When I was working inside that decade box, I had to put in larger wattage resistors because it's all I have.
Right.
So I fit them in there. I'm looking at the pile of resistors in the box, and there's lots of space here. And when I went to put the box back together, all the resistors I put in were interfering with the box, every one of them. In fact, the existing, like the original resistors were sort of just installed just well enough that they cleared the box when you put it together. So just another frustration. Okay, that doesn't really want to go so
I was also
easily.
thinking, once you get this sorted out and you've got two resistor values, and say you've got two and it's not quite perfect, you can then put your decade box across one and vary it and see if you can find a resistance that will trim it into 0 volts, and then add that resistance in parallel with the existing fixed one that you got in there.
I was thinking about that, how to use these variable resistors in various combinations. Scott, did you take my solder? What happened to the... There
I
it
think
is.
I knocked it on the floor.
There it is. Okay, we just got to attack the second. There we are tacked. Let me just make sure. Okay, now the resistor is set who knows where here. Okay, that's very roughly where it needs to start out. I will measure it here. So we're starting out with what? What's it doing? It's jumping all over the place. Clip leads, you know, you gotta love them, gotta hate them at the same time. Oh, I see. Oh, that's right. That's connected right. Okay, I think I got a reading now. 90 ohms. So we're going to get her up around 150 again. It's a hair trigger. 130. Start there. Clockwise increases it. Okay, put the voltmeter back on the transistor collectors. I got a note from Jim in the States, another guy who seems to never be wrong. The other guy who had guessed it was probably this wire wound resistor problem, telling me that minor voltage changes in this arrangement can have a big effect on the output of the transistors. So he's basically telling me I got to be a lot more precise in what I'm doing than I would if this was vacuum tube type equipment. How's that sit with you over there? Sound make sense?
Yep.
Yeah, I think so.
Well, you're making a very small change, and that is going through 3 transistors.
Getting amplified.
Getting amplified, right?
Yeah,
so
yeah.
Kind of propagates through the circuit and gets bigger as it goes.
Yeah, they really are very different in how they operate, transistors and tubes, of course, because one's a current device, the other one's a voltage device. Okay, I think I'm set here. 20 volts on the voltmeter. Everything looks good. Okay, we're starting. Here we go. We have the same minus 13 volts there. I don't feel very hopeful now. And now we're getting ready to adjust. Okay, adding in more and more resistance. Voltage is going down, but I'm adding in a vast amount of resistance now. It's down to 7. Down to 6. Wow, barely. Getting down to 5. But I'm adding in all thousands of resistance here. Thousands of ohms.
Okay, that's not probably not very good then.
This is not a good sign. Okay, and the wires I'm sure are connected. I'm looking right at them. Wait a minute. Is this correct? This is correct, eh? Yes, it's correct. And I did reverse it as you suggested for sure. And so we're floating at minus 5 volts now between the collectors, and so you know what could have happened here, eh? I mean, this component could have failed, and then that's caused other components to fail because of the hard operation after that, like the wire wound resistor. Or it could be the other way around. It could be something went berserk.
No, you were getting it to 0 when you were messing around with the intermittence of the wire wound resistor, the original RV5 there. You were able to get it to pretty close to 0. So here's the suggestion then. Instead of doing it the way we're doing here, which is really not operating it like a pot, like RV5 is wired.
Right.
Take that wire wound resistor, the 3K resistor, and put, say, you know, a 300 or 400 ohm resistor across its 2 outside terminal, and then just connect it in the way RV5 is. And it'll still give you a variation when you move the wiper from one end to the other.
That's certainly.
It might be enough to give you the effect you need.
That is the kind of thing I was thinking. You know, we just need to get it right. It doesn't matter how we get there, really.
Exactly. And you really need to have, you know, not much, probably more in total than 300 ohms between the 2 emitters of transistor 4 on both channels there, because those, you know, that emitter resistor is basically setting the bias for the amps, right? So you don't want to have it too far out from where it is.
Okay,
so you take a 300 or 400 ohm resistor and put it across that 3K pot, and then just wire the 3K pot in there and give that a try. And I think that might get you closer to what we're trying to do here.
considering I got one resistor in there right now, just the way it is. What if I just tack in another resistor and just see what happens? Just pick one close to 150 and stick it in there. Or in this case, it would have to be a little less than 150 to try to match the position of the slider originally. I mean,
Okay,
just because
confirm for sure that if you put 2,
just because it's easy to do, I think.
yeah.
So I would need something like a 130 to go against the 150 that's there. And the 150 that's there is definitely 150. 130. Okay, so I'm going to hunt up some resistors here. Okay, so what I've done now, because Scott, you and I were chatting about this while I was doing the soldering, is we have one 150 resistor. We have another 150 resistor. And then across the one of the 150 resistors, I still have the 3000 pot dialed up to 3000. And you know what? I've done this whole thing with this amp on. Cheapers. I never turned it off. That's probably not particularly good. Probably not a particularly good situation.
Oh, nothing blew up, so obviously you were being very careful.
No, I was being completely reckless. I just was lucky. Okay, so I'm going to set the voltmeter now to read the collector voltage again. You know what's going to happen after I finish this? I'm going to be more inclined to do more transistor stuff.
Nothing wrong with that.
So my comfort level's going up. Okay, well, we're starting out with minus 12 volts. 12 volts. Wow, it's just so far out. I don't know how this. I'm sure this is really some other problem causing this. Okay, I'm going to turn the control here, but I can't imagine it's going to do much. Oh, well, you know what? We got right down to got down to minus 2. What happened there? It's all over the map. Hey, we're down to minus. Whoa, maybe my soldering didn't take here. We got down to minus 2, and then it's all over the place again. Something's not right. Maybe this control is wonky. Yeah, when I was checking these wire wound resistors with my own meter last night,
Yeah.
trying to find one, they were all over the map. Like the sliders are making bad contact. Okay, I can get it down to minus 2 volts here. But exactly why, I don't know, because...
Was it always a negative when it started, or was it positive?
It's never crossed. It's just stayed negative.
Well, it's just the way your meter's connected. There's
Okay.
really no positive or negative.
What is going on here? There's something wrong with the wiring that I've done. Some wire is loose somewhere.
Why? What's happening?
Well, I get minus 2, and then I go to put down the control so my hands are free, and as I let go of it, it jumps up to minus 13. It's all over the place there. Something somewhere. Something somewhere. It's not doing what we thought it should. Okay, so I put the control down, it says minus 11. I wiggle all the wires carefully, and it doesn't really change much. Pick the control up again. I gotta use pliers on it.
The control might be at a very touchy spot right at the end of its travel.
Oh, I think it might even not be contacting the... So what I'm doing now is the contact is exposed on this. I can push it up against the... That's a piece of crap. This... I think all we can say is that this is completely inconclusive because the wire wound resistor I'm using may be wonky. Oh, I think I saw positive 4 for a moment. No, maybe it was just minus 4. It's just, you know what else I'm doing? I'm using a digital meter when I should be using an indicating meter. Because the numbers are flying all over the place. You can hardly get a grip on what's happening. It's not the easiest thing for me to whip out a meter here. An indicating meter. I could do it though. But it's sitting at minus 13 right now. I can't get it to stay around minus 2, and I don't know why it's even showing minus 2. It could just be a flitty thing on the meter. Or that control is a piece of junk.
Sounds more like the control is iffy. To me. It's jumping around like that.
Seems that way. Let me, I'm going to nip one control wire. soon as I can find my cutters. What? Scott, did you take my cutters now? Every time I turn around, you're taking my stuff.
I think the cat has it.
There they are. Here they are. Okay, so we'll nip off the control here. We're at minus 14 right now. Control gone, we're at minus 13.
Why don't you clip your decade box on there and see what you can do with the lower end, or, you know,
Sure.
you can get it anywhere near with that.
Sure, so I'll set it up high. We'll go across one of the... Basically, there's two 150 ohm resistors now in here. So in a sense, the control is set to the neutral spot. You know what I mean? The center spot.
Right, yeah. So you can put it on one side or the other and see which way you can get it to correct.
That's what I'm doing. Okay, now my decade box is a little bit random. Oh, son of a gun. The meter wasn't really visible on camera all that time, doggone it. Okay, let's see, we're at minus 11. What I'm doing is I'm reducing the resistance of one of the 150s. We went up a little bit, minus 14, minus 12, minus 12, minus 13. I'm down to a fairly low resistance now. It's just staying at minus 13. Okay, so now we'll try the other side, the other resistor. I'm really feeling quite hopeless about all this now. That's, you know, that's why it was good to stop yesterday. Stop yesterday at a point where you think you're on your way to solving it. Enjoy my day. And come in today and find out, no, that's not really the case. Okay, so we're going to try it again. I'm going to reduce the resistance of the other resistor now. 11 volts there. These first few steps are so high it can't really make much difference. Here we go. 11.6. 11.6. 11.5. 11.6. Just doing nothing.
What resistance are you set at?
Right now, I think it's somewhere around 50 ohms. 11. It's just doing nothing.
Are you sure the clip leads are good?
You know, as sure as I can be. These are good clip leads on this particular box, and I have no reason to think they're not making contact. So I just disconnect the box. Wait a minute. Let me set it back to this is definitely 35 ohms, no doubt about it. 35 ohms across the 150. We go from 11 to 11. It just makes almost no difference. I tried the other resistor again, just double checking back. 33 ohms going across it. Went up 13.5 volts. That's a pretty distinct change there. Went up as I reduced the resistance. Reducing the resistance of the leg that was reduced by the original control, if you know what I mean.
Right.
So wow, this just isn't going anywhere. I'm getting nowhere. We've gotten nowhere, except that we now know that this isn't the be-all and end-all of the problem, I think.
Well, maybe the solution is to just do the repair as best you can on RV5 as it is, and get it working. The original wire one resistor there. Because RV5 is the emitter resistor for the two transistor 4s for the two amplifiers. You're basically just setting the base bias on those by varying how close that emitter goes to ground. Right? And you're just varying it between the two just to kind of balance them out.
Well, I'm really not hopeful on getting that resistor to work again. The original...
Are there any electronic shops in town you can hit and maybe pick up a...
No, there's nothing here at all. But I'm kind of convinced that this is not the solution to the problem, and that what I'm thinking is whatever else is wrong is making it impossible to balance this control. It doesn't matter how much we try. We're never going to get it to balance. Or am I measuring too, as you mentioned, the effect of this resistor is kind of amplified through a few transistors to the one we're measuring.
It is, yeah.
But you know what?
The collector of transistor 4 connected directly to the base of transistor 6, and the collector of transistor 6 is connected directly to the base of transistor 8. So you've got like 3 transistors there, right, in series. So the current amplification is going to be quite high, I think.
And while I'm doing this, it's affecting both amplifiers. And I don't have the speakers plugged in.
Well, yeah, having the speakers out just keeps the big fault current from flowing in the woofers. But I just had an idea looking at the schematic here.
Are you sure? Here, let me put the schematic up. I'll take a look at it with you here.
Because when you get that DC imbalance between the two outputs, that DC basically goes directly to the woofers.
Well, that's right.
Right. So maybe what you could do is, this RV5 is a 300 ohm resistor. Basically you've got a 150 ohm emitter resistor for each of the two transistor 4s.
Right.
On the two amplifiers.
That's right.
Going to that supply common there. Maybe what you can do is just take 150 ohm resistors, 2 of them, and connect them together. Connect the emitter directly to the B plus or B minus, whatever that is there. Forget about the wiper, right? Just connect it so you've got the emitter.
Well, that's kind of what I've...
transistor going to that through 150 ohms.
That's exactly what I have here now. I have 250 ohm resistors in series, and in between them is the wiper lead connected.
Okay.
So it's exactly...
So in that case, what I would do right now is just ignore the woofers and see if the amplifiers are working. Like put your scope on where the speaker would connect to each channel. You know what I mean? Where pin 6
Yeah.
and pin 4. One at a time, and check that both amplifiers are actually working, because with that 150 ohm emitter resistance there, the circuit should be biased to the point where it's probably working okay. So you've got if you get the 2 amplifiers working, it's just that they're not biased exactly right to get a 0 difference between them on the output.
Yeah, but
what you can do is just put like a 1,000 mic cap or something in series with the woofers, and just run it like that, and not worry about trying to balance out that DC. The only reason you need to balance out that DC is they saved a huge capacitor when they built the thing by not having to put it in series with the woofer.
I follow what you're saying. It's a fair bit of effort to get there, so that's why I'm hesitant to jump right into that. It's a fair bit of monkeying around to get all that set up.
No, not really. It's already set up. Like you said, you've got the two 150s connected from the emitters basically to the B plus or B minus, whatever that would be there. I guess that's B plus. So the 2 amplifiers should be working in theory if there's no other faults in there. And the only difficulty you have is when you connect the woofers, you're kind of putting a DC load across between the 2 amps because they're not perfectly matched. If you put a cap in series with the base speakers, you solve that problem. You don't have that DC fault current, and yet you've still got the 2 amps working.
Yeah, I follow. I'm just sitting here looking at it, thinking about how am I going to do all that. I don't have a non-polarized large cap like that. I got some smaller ones, but I don't have a real big whopper non-polarized. Or I guess that doesn't matter.
About 1,000 microfarads or something. Not too huge, but
And the whole reason to do this is just for the sake of testing to see if the amplifiers are operating at this point.
Well, you might just be able to leave it like that and have it working, right? Because if you can't get a pot that's going to perfectly balance the bias between the two outputs, then, you know, it's going to be impossible to get the thing to work with the woofer connected directly, right? But if you put a cap in the woofer, then you don't have to worry about the 2 amps being exactly balanced. They'll still work just fine without it being the DC bias between them perfectly balanced.
It's tough to set this up in the shop here.
I
know it is. I have to hook up the speakers. I got to get the capacitor. I gotta connect the speakers in some kind of reliable way. And talking about tiny little pins on a cable here. I don't know which pins. Well, I guess I could figure out which pins are which.
No, but you've got the wire going into the cabinet where the speakers are, right?
But,
you just put the cap in there. It doesn't matter really where it is.
Yeah. Well, you mentioned using the scope. Why not try to do some test without the speakers hooked up?
Well, yeah, that was the first thing you do. Is you
Well, let's do that.
hook your scope up. You're going to have, you know, the 12 volts or whatever, half the supply voltage basically to DC coming out of that collector of transistor 8. But you should get the AC audio signal through. Pretty good. To confirm that your amp is actually working, and if you're getting a sine wave out when you're putting a sine wave in, you know it's not hard over biased, saturating, you know, a transistor somewhere.
Okay, so what I'm going to, let's see. If I want to put the scope on so it's sitting where the speakers normally are.
Yeah,
That's
same where we think like you measured the voltage. You go from the common, the power supply common there, to, you know, the DC, the collector of transistor 8, essentially.
Oh, is that so, eh? Is that what it amounts to?
Because the power supply common is what goes out to the speakers, one side of the speakers.
Okay, so I can go on the collector. The collector has the 1 ohm resistor on it, does it not?
Yeah, but the 1 ohm resistor, either side of that 1 ohm resistor is going to be very similar.
Yeah, well, the 1 ohm resistor marks the spot on the circuit here for me to be sure what I'm doing. So I put the scope.
So you connect your scope on there.
And the scope ground just to the chassis? No.
Yeah.
Yeah?
The chassis is the common, right?
Believe so. Okay. Let me just change my camera angles here a little bit. There we go. So I'm trying to get a view on the camera of the scope in the background and the circuitry in the foreground. Okay. And again, I've left this thing on. I keep forgetting it's on, even though the light is staring at me. Okay, well, right off the bat, we got something on the scope here. It does look like a hum. Okay, so I'm looking at the channel we've been questioning all along. I'll feed a signal into it, just be a hum signal from my finger. Something going on there on the scope.
Don't forget you got the volume control has to be turned up as well to get some audio through.
No, don't make me turn up the volume. Okay.
So you won't hear anything.
Well, it's not that. It's just that getting at the volume control without shorting something, you know. Which way's up? Oh, okay, I can see from the scope which way's up. There's definitely a hum there. It's a distorted hum. Lots of weird stuff going on. Oh. So my scope is set to AC right now. So it was jumping all over the place. So there's some DC coming and going. Okay, so there's clearly some kind of output from the amplifier. I'm putting my finger on the input lead and you just get this wild schmozzle on the screen.
Yeah, well that's just the sure you've got a proper
I'm going to the other side.
fidelity, then just put something from your audio generator in, like a sine wave, very low because it's going to be the phono input, right?
Yeah. Okay,
And
I'm
then
on.
just see, you get a nice sine wave out. You know, the amplifier is, biased somewhere in the middle, and
Okay.
you're not.
So I've switched to the other. Oh wow. Okay, huge difference. I've switched to the other channel.
Yeah.
Very same test. And what I'm getting here when I touch the input is it just goes right off the screen of the scope. A gigantic amplification of what is clearly a hum. Yeah, so changing the sensitivity of the scope, no signal shows a flat line, and then when I touch the input you can see the hum. That's the channel I believe is working. I go back to the other one. You know what? It looks the same.
All right.
Okay, so you're thinking to go a little further
I'm
now.
thinking that the two amplifiers, independently they work just fine. The only difficulty is they have to be matched with that output bias just to get zero DC going to the woofer. So if you use them just the way they are now, put a cap in series of the woofers, and you're laughing, and it works.
I like the laughing part. And you just leave this thing out of balance.
But you can't, it only has to be in balance because of the fact that the woofer connects from one side to the other. If the woofer has got a cap to prevent the DC, then the balance really doesn't matter. The two outputs can have a couple of volts difference and really no effect.
So I've got a big capacitor here, 1000 microfarad, 200 volt capacitor.
Well, just look at the polarity of the imbalance and connect that cap in the correct polarity for the DC that's going to be across it, and see what it sounds like.
The easiest and the easiest and most effective way would be for me to plug the speakers back into the plug, take a wire, the right wire off the back of the plug terminal, and insert this capacitor.
Yeah.
And that would probably be the easiest and best approach. That way all the speakers are connected, and everything is just about the way it would be.
Right.
How
How easy is it for you to determine which wire it is going to? Because you say that plug has more.
I think that's very easy because I can see one of the wires going to the choke coil from the plug. So
Okay, well, there you go.
So it's really quite easy to identify for sure which wire it is, but I should take a polarity or a voltage
you want to
measurement.
look at take a polarity and then put the cap in.
Can I take a polarity just as it is right now?
Well, it has to be running and it has to have the speaker connected. So I would say turn it off, plug in the speakers, cut that wire, strip it off for 10, and then put your meter on it, turn it back on, and then find the polarity. Turn it off, put the cap in.
How come I can't just figure out the polarity right now?
Well, you need the power on for the.
The power is on. I think it's sitting
Yeah.
there. Yeah. Isn't the
You need to
voltage?
clip the wire going to the woofers and then look at the polarity that shows up across it.
Well, you see, I don't need to clip the wire. The wire goes to a dead terminal, just to an open terminal. Oh no, it goes. Yeah. Basically, it goes to an open terminal. Anyway, okay, I don't want to argue with you because usually in these situations I'm wrong anyway. So why
Well,
drag
there's
out?
many ways to do it. I'm just looking at the easy way.
No, you think it's easy. Yeah, easy on a phone. Okay, so I'm going to make a little voltage reading here. Let me just flip my camera around again. Here. Okie dokie. Well, yeah, it's never worked out for me when I go against your advice, but I'm going to try and see if I can't determine a polarity just with it right now. Polarity to the chassis. So I get minus 11 volts. Minus 11 volts.
Well, it's going to be the polarity relative to, in series with the speaker. Is it a positive on the way to the speaker, or is
Right.
It's on the way to the speaker. I don't.
Right.
You don't know which way around to put the cap.
Okay, so
Doesn't matter what it is relative to the chassis.
power's off. I can cut either wire that's going to the inductor. Blue one.
Whichever one's easiest to get at and hook a cap to would be how I would go there.
They're kind of the same. I want to make sure there's only one wire there, not two. There has to be two on one of those terminals. Wait a minute. Oh, hold on. Maybe I got the wrong terminals here. Let me look at the schematic for a second. Or I boob up. Okay. So according to this, it should be either number 6 or number 7.
Well, according to the schematic I've got from you,
Yeah.
it should be going to number 7.
Yeah,
number 6 is where the speaker.
Number 7 goes to the inductor. 987, green wire. That's it. That's the one. That's the sound of the wire being snipped.
Power off?
Yeah. Well, it wouldn't matter in this case. The wire's going nowhere anyway. Right? It's on its way to the speaker, but it's not getting there.
Yeah, but you're messing around in the power supply chassis there, so
That's right.
Could cause some surprises.
Why? You have no faith in me? You think I might,
Lots of faith, but
you think I might do something wrong?
We've all made little mistakes.
Yeah, but I'm the only guy who puts them on video and publishes them. Okay, I got the wire snipped. So now we got to stick this capacitor in here. No, first I got to make the polarity measurement.
Right.
Polarity determination. So, but it's an open terminal anyway. I'm sure I didn't need to do that. Okay, but I got to do it eventually, I guess, in order to hook up the capacitor. So now, well, I should plug the speakers in at this point.
Yeah, you have to have the speakers plugged in. You
Yeah,
don't have
okay. Power off.
a voltage to measure.
So the theory, so now once I have the speakers in, the tweeter and mid-range are going to start activating.
Yep.
Maybe that's all I need to do this test. What do you think of that?
Well, you would be able to test the tweeters and mid-range are working, but you might as well.
But that would prove the amplifiers are working.
Right, and then go from there. Then put some cap in.
Okay, so I have the speakers plugged in. I have a wire off that goes to the woofers, so the woofers are out of the circuit.
Right.
So with
Good
the
plan.
good plan. Good thing we just kind of stumbled into it. The plan has presented itself. Okay. Now we could get a surprising result here. I got the volume cranked up full, so I'm going to turn it down. At least what I think is down. Let's see, turn it up. Oh, I think I had it up all the way. That feels like down. Probably not even the volume control I'm turning. I probably just turned it the other way too. So this could be a surprisingly noisy event here. Just closing my shop door. Okay. Shouldn't be noisy when I first turn it on. It's when I inject the hum signal that blow our ears off. Just
Correct.
looking and seeing that everything is okay. Okay, everything's okay. I'm okay. You okay?
I'm okay.
It's on and it's humming. It sounds like an airplane. Out of one channel. It sounds like an airplane crashing. I cut the power off there because I got nervous. What do you think? No reason to be nervous?
How did it vary with the volume control?
I didn't do anything except stand here paralyzed looking at it thinking, oh. No. That sound was coming out of the working channel. Doesn't sound so healthy anymore. Okay, just try it again. I guess. Just making sure there's no accidental shorts here. And then we'll do the finger injection thing. Ooh, did you hear that big wonk? When I turned it on, there was the click of the switch, and then there was a wonk out of the speaker, and there's no wobbly.
Lead, hanging free, Clark?
Hey, listen. Okay, listen. Okay, so that's the channel that was always working. Still seems to be working. That's a good sign. Now here's the other channel that never seemed to work. Can you hear that? You probably can't hear that.
No.
So it sounds exactly like it did way back when I first started doing this stuff. Instead of a nice warm hum, it's making a horrible clicky sound, as if something is in cutoff and coming out, you know what I mean?
Right, okay, well then what I would do is now go through, that voltage table that's on the service notes there.
On
It
page
shows you
2?
the voltages that you should be seeing on all the transistors.
There's some staticky clicking coming out of it. But, well, you heard that, I'm sure.
Yeah.
I'm just standing still. So, I don't know what that was, but
Well, you could still have like a leaky gap somewhere in one of the amps.
certainly. Okay, verify all these voltages.
On the bad amp, you should be able to find if one of them is way out. You can see where the difficulty is. You might have a blocking cap that's leaking, showing the bias way off on the transistors.
So in the end, if I do the capacitor trick to block the DC from the base speakers, then setting this bias thing is no longer critical,
Right.
as long as it's reasonable enough. I mean, obviously you could still have it far enough out that. So
Right,
now,
but at
you know
this
what?
point, it looks like the one amplifier definitely has a problem that's not related to that bias. That might be causing that bias problem. Right, because you've got the 150 emitter resistor in for TR4, so that's in its proper range. So you just go through and check those voltages and see, from transistor 1, transistor 2, you'll get to a point where you'll find one's way off, maybe, and that'll be pointing to you where it looks next.
Now think about this for a minute. So I found this wire wound resistor, assuming it was defective, and I didn't make it go defective by poking with it. Assuming it was already defective, I'm pretty sure that's the case. Then this amp was operating in a state with that set totally wrong. Totally, I mean, it's open circuited. Now I've got fixed resistors in there, somewhere in the range of where they should be, and I'm getting exactly the same operation of the amplifier. Isn't that a little weird? Wouldn't you think, okay, with the slider control shot, the amp would behave one way, and with a good set of fixed resistors in there getting it close, you'd think it would behave quite differently, but it doesn't.
Well, it looks like to me in case there's more than one problem. It seems to me that RV5 is definitely wonky. Right? Because you really didn't do anything to it. You measured it was open across the outside terminal.
Okay, hear that?
It was
Hear that?
definitely wonky.
Hear that? That's me moving the questionable board just a little bit. That's moving a lot of stuff when I move the board.
Right. Well, there might be a cold solder joint in there. There might be a wire that's kind of iffy.
Remember, there were some tests I did earlier that sort of suggested something like that. And then other things I did that suggested that's not the case. I could go through and just resolder everything.
Well, that's a bit extreme, really, at this point. I would start going through that voltage chart and see how far out
something here, that's for sure.
That really shouldn't be happening if you move it. So obviously you have an intermittent connection in there somewhere.
Something. I'm trying to isolate it. But I think you had mentioned before you saw that when I moved the black lead wire.
Yeah.
No, that's
It's scratching this when you were moving that.
yeah, no, I think that was probably bumping the board because I'm moving it a lot now and nothing's happening.
Yeah.
But the only thing that is getting flexed here when I do this is the wires that are coming onto the board from the rest of the circuits. I mean, the board itself is not getting flexed. None of the parts are getting flexed. Oh, okay, so now I'm there's a bundle of wires that go up to the controls on the panel. And so I'm wiggling those wires in different places here. Wow, the sensitivity is really sensitive over here. It's almost like a microphone. What if it's just a dirty control? Wow, I'm right in there somewhere. It's not the resistors I put in. I can wiggle that whole arrangement and nothing happens.
Right.
But there's a bundle of wire. I just touch it.
Here's an idea. Right now, take your meter and measure from the chassis, the common, to the collectors of the two transistor 8s. And that really should be around half the supply voltage at the collector of those transistors. If the bias is anywhere near where it should be.
Okay, on all four of them.
No, just the two transistor 8s. The collector should be somewhere in the middle, halfway of the supply voltage.
And what is the supply voltage?
Supposed to be around 25, but on restricted it might be slightly less.
Minus 11.
It's only 11 volts, the supply.
That's what I think I just measured. Am I on the right stuff? Maybe I'm on the wrong. You know what? No. I was on. I was on one of the capacitors involved in the crossover.
Did you put a new meter in your battery in your meter?
No,
Because you might be getting wonky readings with the low battery in your meter.
I don't think that's the case yet. Okay, well I got over 20. Hang on. I just was measuring in a stupid spot. 20 is 20 volts. It was 20 volts. 23.2 volts.
Okay.
So we should be
So
looking
the
at.
collectors of the two transistor 8s should be somewhere around half of that.
Okay, so one is minus 10 and the other one is minus 12.
Okay, so those things are well within the range of where they should be.
Yeah, actually,
They're not being hard over.
Actually, checking them more closely, they're both right around minus 11.
Right. So they're pretty close to where they should be, half the supply, right? Because it's a Class A-B kind of push-pull
Yeah.
output.
And
So you know you don't have a hard-over bias problem causing the problem, right? So you're not getting much of an output. Sounds to me that you need to check the bias on those earlier transistors from that chart on the bad amp and just see where the problem is. You might have a bad blocking cap that's preventing the audio signal going through. You can just even use your scope. Put an audio signal in from your signal generator and just look at the signal coming out of the collectors of transistor 1, transistor 2, transistor 3, and just see where the signal is going to get to.
well, both those tests sound pretty good. I think what I did do is I tried comparing the voltages and resistances of the two boards. I never found anything significant, but I can do it again because now I have the table. I didn't know that table existed earlier. So I could do this, check the transistor voltages, or do the signal thing. They're both pretty interesting. The voltage thing's pretty easy to do. Where are we on the clock here? Just about the end of my time for working today.
Right.
So maybe what I'll do, I'll leave it at this, and then
Tomorrow.
we'll continue tomorrow, and maybe during the day at some point I can get in here and I'll do the voltage tests and see if we find anything, if I got time. I don't know. Weather's going to be good today, Scott, but then rainy later. You gotta
What's that?
Said the weather today is going to be good until later tonight, and then rainy in the evening apparently. At least up here. Maybe not for you.
Well, let me have a look on the radar's completely clear right now, and according to this, we get rain here Thursday in the late afternoon, 40%.
Yeah.
And today is supposed to be 60% showers late this evening and overnight.
Yeah, so I got to get out and do my day work before the rain comes.
Right.
Okay, we'll leave it at
Alright.
this. Anyway, we'll leave it at this and carry on tomorrow. If I manage to get in here and do those voltage tests in the meantime, I'll do it.
Okay, no
We'll
problem.
see. We'll see. Thanks a
You
lot.
don't need me for that.
No, I just need the
Feel free to
result.
call me anytime.
I just need the result. Okay, thanks, Scott.
Okay, bye.
Bye. Okay, hey, I'm back alone in my shop again. What a strange thing it is to have somebody in here with me. But it's fun anyway, and very helpful for me to try to succeed here. Keep an eye on my cameras. So that's it for today. So unfortunately, the wire resistor thing seemed to be a bit of a red herring, but this thing had to be found, had to be fixed in some way before we're going to have any success. Okay, that'd be it. Thanks for watching these very long videos. We'll see you later.